is what is called piecewise functions. And we've already talked about this a little bit. In our modeling with functions, we did a piecewise function. But a piecewise function, this is a function defined by different pieces over different domain intervals. So let's take a look at an example. We're going to graph f of x equals, this is what a piecewise function looks like when you see it written. It's got a giant left-ended squirrely brace, and then it starts defining pieces. X squared if x is less than or equal to -1, and 2x if x is greater than 1. So what's happening here is we're using two different pieces over two different domains. So over the domain x less than or equal to -1, or -infinity up to -1, including -1, the graph looks like x squared and has the properties of x squared. Over the domain x greater than 1, sorry, x greater than, that should be a -1, folks. X greater than -1. Or -1 to infinity, the graph looks like 2x. So how are we going to graph this, first of all? Well, my suggestion to you is to first graph them both separately. So first, graph each piece separately. And the things that you're supposed to be graphing right now should be pretty familiar with to you from Math 127. Hopefully everybody knows what a parabola looks like. You're not going to be too surprised when I draw this. This is x squared, where this is 0, 1, -1, so on and so forth. And oops, let me move that. 2x is a line that goes to the origin with a slope of 2. Come on now. Get on there. Something like that. So this is 2x. I didn't label my axes here, but this is the x-axis. This is the y-axis. Again, x, y, and that's 1, 0, 1. And that's what each one of those graphs looks like individually. And hopefully that doesn't tax too many people. You should be able to graph both of those. Next, what we're going to do is cut and paste. Right? You guys are all getting photos ready for Instagram and stuff like that. Facebook for the older people, right? And you're going to crop your friends out that you don't like anymore, scratch their eyes out, that kind of thing. And so what we need to do here is we need to crop these. So according to this domain here, we only want to use the parabola if x is less than or equal to -1. Well, here's where it's equal to -1, and this is the portion of the curve where x is less than -1. And on the red curve over here, here's where x is equal to -1, and this is the portion where x is greater than it. So what we're going to do is we're going to cut and paste here, and then we're going to join them together. So let's see if I can fit this all in one page. Now let's go down. This is crazy. The result of cutting and pasting this is, let's talk about these features. This is the point -1, 1. So we want to go to the point -1, 1. And we're going to have a solid dot there. Why are we going to have a solid dot there? Well, we're going to have a solid dot there because this is where the equals sign is. So that's going to be our solid dot. And then after that, to the left, it is going to look like the parabola. So let's see, this goes 1, 2, 3, 4 to that point, and it kind of comes up. Oh, come on, stop it. I'm not trying to draw a line. Looks something like that. That's the portion that is x squared for x less than or equal to -1. The other portion of this, let's see, what point is that? That is the point -1, -2. But at that point, we should actually have an open dot. Number one, this is a function. I can't have two closed dots right above each other. But you'll notice here that this is not equal to. And so I have an open dot there, and then it just goes about its business. Something like that. And this is 2x, provided x is greater than -1. And that is what this piecewise function looks like. And it gets its name piecewise simply because it's defined in pieces. It is a Frankenstein curve, right? Cut and paste, Photoshop stuff. And that's what a piecewise function looks like. And this is f of x equal to x squared whenever x is less than or equal to -1, and 2x when x is greater than -1. Now, in the book, they also define these with up to 3 pieces, but you can define it in as many pieces as you want.